Hey, moving on to 1-6. Objectives today. We're going to create and solve a system of inequalities, and we're going to interpret the solution to a compound inequality within a modeling context. Okay, so basically what we're looking at today is compound inequalities. Okay, that means one or two or more inequalities joined together to describe the same situation. Okay, so we're going to look at what happens when we have two or more inequalities together. Okay, so this is 1-6 compound inequalities. So the first thing they're going to show us is a graph. We want to use inequalities to describe the set of numbers graphed below. Okay, so notice we have two different arrows going two different ways. So the graph shows the solutions of two inequalities. The two inequalities form a compound inequality. A compound inequality is made up of two or more inequalities. Okay, think about English class. Talk about compound words like doghouse, two words put together. These are two inequalities put together. So I want to describe this graph. We can take a piece of it at a time. So we can focus on the solid circle going to the left of the -3. How can we write that as an inequality? Well, x and the -3. Now, am I going to the left or to the right? Going to the left, so that's less than. And it's a closed circle, so I'm equal to. Okay, if I look at the other one, that open circle there with the 2, I'm going to start with x and 2. Now I'm going to the right, so that means greater than, and it's open, so I do not need the line. Okay, so I have x is less than or equal to -3, x is greater than 2. Now, can you have a number that fits both of those situations at the same time? I can't think of any number that works for both. So only one can happen at a time. This one or this one. So this would be x is less than or equal to -3 or x is greater than 2. Okay, can't happen both at the same time, so we use the word or. Okay, x is less than or equal to -3 or x is greater than 2. Okay, here's my next one. I have -4 and 1. Okay, a closed circle here, open circle here. Notice I'm in between. Okay, so we can look at it this way. We can pretend this one goes on forever, this to the right here, and we can pretend this one goes on forever to the left here. So let's describe one at a time. Okay, so I see a -4, so I'm going to do an x and a -4. Now looking here, my arrow goes to the right, so I'm greater than, and I'm closed, so it has to be equal to. Okay, down here, I'm going to put the x, and my circle's on the 1, so the 1 goes here. My arrow is going to the left, so I'm less than. It's open, so I do not put the line underneath. Okay, so can we have a number that is greater than -4 and less than 1? Can that happen at the same time? Absolutely. Notice 0 is included here. So they can happen together, so we're going to use the word and. X is greater than or equal to -4, and x is less than 1. Okay, that is one way you could write this inequality. Let's look at it a different way. Okay, I'm going to start with -4 on one end, 1 on the other. Notice my arrow goes in between, so I'm going to put x in between. Now looking over here, did I put the mouth eating the x or the -4? It's eating the x, so I'm going to put an arrow here, eating the x. Okay, looking at the 1, am I eating the x or the 1? I'm eating the 1, so I'll put my arrow here. When you do it all together like this, you always should put the numbers in order from least to greatest. Okay, and then you'll notice that your arrows will point the same way. Okay, so 2 ways to write that. Okay, so the compound inequality that describes this graph is -4 is less than or equal to x, and x is less than 1. You can also write it as I just wrote it in between. Okay, your turn to try. Please pause the video and try this problem. Okay, again, there's 2 ways. I'm going to do it this way first, the x in the middle, because I can tell this is an and inequality. Now, I know both of my arrows are going to go this way, so I'll start with the -2. It's open, don't need a line. Oh, the 6 is closed, so I need a line there. Okay? You could also look at this as I'm going to do x in the -2. I'm going to the right of -2. So I am greater than the -2. Open circle, so no line. Okay, I'm in between, so it's an and. I'm going to do my x and my 6. Well, the arrow goes to the left of the 6, so I know I'm less than, and it's closed, so underline. Either one of these answers is acceptable. Alright, so let's talk about how to solve these. So we're going to start with an OR problem. Now we like ORs, they're super easy. We're just going to write it as two separate problems. So I'm going to start with saying 5x minus 7 is less than 13. Then I'm going to put the word OR real big just to remind myself. And I'm going to do this guy. Negative 4x plus 3 is greater than 11. And from here, it's just a matter of solving. So let's concentrate on the blue guy first. Got to get x by itself, so let's add 7 to both sides. 5x is less than 20. Got to get x by itself, so let's divide by that 5. X is less than 4. Okay, let's concentrate on the red guy. Get x by itself, you need to get rid of that plus 3, so minus 3. Negative 4x greater than 8. Got to get x by itself, so let's divide by negative 4. 8 divided by negative 4 is negative 2. Oh, I divided by a negative, so what does that mean I have to do? I have to flip the inequality. Okay, so let's go ahead and graph this now. Okay, if I put this on a number line, I'm going to put negative 2 down here and put 4 up here. Again, I'm pretty lazy when it comes to these, so let's start with our purple first. X is less than 4, that's an open circle, and I'm going to the left. Okay, the green guy, x is less than negative 2, open circle, less than, I'm going to the left. Oh, this one looks funny. Okay, normally when we look at ORs, they go two separate directions. This one goes the same way. Now, here's the tricky part of this one. Okay, the final graph is all points that appear in either solution. Okay, so it doesn't have to be in both, it could be either. Okay, but notice this green line is included in the purple line. So with this one, I really don't have to draw two graphs at all. I just want to include the one that has all of it. Okay, so the 4 and on. Because everything in the purple, the green is also included. So I don't have to list it twice. So my final solution here is x is less than 4. Okay, and this would be my final graph. Okay, your turn. Please pause the video and try this problem. Okay, so again, I'm going to write it again because I like having room to work. So I'm going to write the first guy. I'm going to write the word OR really big to remind myself. And I'm going to write the second guy. Okay, let's solve the blue guy. So I get x by itself, we're going to subtract 2. Negative 7 minus 2 is negative 9. Divide by that negative 3. Oh, I divided by a negative, so I got to flip that sign. Negative 9 divided by negative 3 is a positive 3. Okay, solving the red guy. Should probably distribute first. Okay, get the x by itself. So 2x is greater than or equal to 10. Divide by 2. X is greater than or equal to 5. Okay, so let's throw this guy on a graph. Again, I'm pretty lazy when it comes to graphing these. Start with the green. I am less than 3, so it's an open circle to the left. Purple guy, I'm greater than or equal to the 5, so I'm going to be a closed circle on the 5. I'm greater than, so I'm going to the right. Okay, notice this one is what we usually think of when we have an OR compound inequality. And that's how you do that. Alright, so next one we're going to talk about is an AND problem. Now I'm going to show you two different ways of solving this, and I don't care which way you use. Okay, so my first method of solving, I'm going to actually split it into two problems. Now the first problem I'm going to look at is I'm going to go till I hit that first sign. I don't care about this guy. My first problem is negative 12 less than or equal to 7x plus 9. Actually, let me get rid of this line because I'll worry about the second method later. Okay, and since I'm in between, I know this is AND, so I'm going to write AND really big. Okay, so to get my second problem, I'm going to do the same kind of thing, but this time I'm going to get rid of the first sign. That's not what I want. I want what's left on the right. So 7x plus 9 less than 16. And from here, it's just like solving a normal inequality. Subtract the 9 from both sides. Okay, divide by that 7. Negative 3 is less than or equal to x. Solve this guy. We're going to subtract that 9. Okay, and this was an AND, so I can go ahead and actually put these back together. I'm going to put the negative 3, I'm going to put the x, and I'm going to put the 1. Okay, right here, notice my sign is eating the x. Notice right here, I'm eating the 1. So I have my inequality now to graph. Okay, the purple, notice I have a closed circle. Okay, the 1, I'd have an open circle. And this is an AND, so I'm just in between. That's what my answer would look like. Okay, that's the first method. Let me show you a second method of solving this. Okay, let me just go look at the problem again so I can rewrite it. Negative 12 less than or equal to, I'll do it down here. Negative 12 less than or equal to 7x plus 9 less than 16. Okay, so if I want to solve now, my goal is still to get x by itself. So I'm concentrating here in the middle. Okay, I got 7x, oh, I got this plus 9 hanging around. So I got to get rid of that plus 9. So I'm going to subtract 9. Now here's the difference. Notice I have 3 sides. So I got to do it here in the middle, got to subtract over here, and subtract over here. When I do this, I get negative 21 less than or equal to 7x less than 7. Okay? Still, the goal is to get x by itself, so I'm still looking here in the middle. So let's divide by 7. Again, I have 3 sides. So divide by 7 here, and divide by 7 here. Now I get negative 3. Keep the sign the same. The x, 7 divided by 7 is 1. And it gives you the exact same problem. Okay? I don't care which method you choose. Some people like splitting it up because it's a little less confusing. Some people like doing it all in one go. I do not care. Okay, so remember with the AND, the final graph is all points that appear in both of the solutions. Okay, so you really want to look and see where they overlap. The AND is where they overlap. And you could write it like this, or all smushed together. I do not care. Okay, your turn. Please try this problem. Okay, so if I'm looking at this problem, notice they already have it separated for me. So I'm just going to go ahead and solve with it separated. So I'm going to rewrite it just because I like to have a little bit more room. Okay, so solving over here on the left, I'm going to distribute. Okay, get all my x's, so I gotta get rid of that 2. Okay, get x by itself, so divide by negative 2. X is am I less than? No, you gotta be careful here. I divided by negative, so flip it. Okay, x is greater than negative 3. Okay, same process over here on the right. Subtract 1. X isn't by itself, so I need to divide. X is less than or equal to negative 1. Okay, So let's put it together. I personally like to put them together so I can see it a little bit better. I'm going to put it in order. So -3 is smaller. I know x will go in the middle, and -1 is bigger. Looking over here in the blue, my mouth is eating the x, so I need to keep it eating the x. Over here on the right, the mouth is eating the -1. Still eats the -1. And now it's pretty easy to graph. Throw your -3 on there, throw your -1. I have an open circle on the -3 and a closed circle on the -1. And then it's an and, so I'm just in between. And that's how you solve. Okay, last thing we'll look at today is a word problem. So here's some good application to compound inequalities. So Enrique is planning a diet for his dog, River. River consumes between 510 and 540 calories per day. If River eats 1.5 servings of dog food each day, how many treats can she have? Okay, so words that are popping out to me. Between 510 and 540. I also see she eats 1.5 servings of dog food. And finally, I see the special words, how many. Okay, so I'm looking for treats. I don't know how many treats she's getting. So that's what I'm solving for. So I'm going to say x is the number of treats. So let's start setting it up. I'm between 510 and 540. So I know 510, 540. Okay, between. Oh, that sounds like an and inequality. So I know I'm going to have stuff in the middle. So I know my signs are both going to be facing this way. Okay, so if I eat between 510 and 540, do you think she can eat exactly 510 or exactly 540? Probably. So we know the signs are going to be equal. So what does she eat each day? Well, get 1.5 servings of dog food. So we're talking about calories. So servings, that doesn't tell me anything about the calories. So down here, I have 320 calories per serving. So I'm going to have 1.5 times that 320. Okay, plus she's going to get treats. Okay, so plus, do we know how many treats she's getting? No, so we'll call that x. Okay, so now it's set up. Let's solve it. So start with right here, 1.5 times 320. 1.5 times 320 would be 480. Okay, so to get x by itself, I got to get rid of this 480. So I'm going to subtract. And remember, I have 3 sides. So I subtract here, here, and here. 510 minus 480 is just 30. Oh, I forgot something. I'm sorry, guys. We gotta talk about 15 calories per treat. So it's not just x, it's 15x. And again, if we were face-to-face, hopefully I wouldn't make that mistake. Okay, so really pay attention to calories. So I have 30 is less than or equal to the 15x, which is less than or equal to 60. Okay, have we solved for x all the way? Not yet, so I got to divide by 15. Remember, it's 3 sides, so I got to divide everywhere. 30 divided by 15 is 2, less than or equal to x, which is less than or equal to 4. So she can have between 2 and 4 treats. Okay. River can have between 2 and 4 treats. And that's how you solve that problem. Okay, so you try, please pause the video and try this problem. It says the same problem, except now, instead of the treats being 15 calories, they're 10 calories. So it's going to be set up identically, except for the 15x is going to turn into a 10x. So I know I have the 510 is less than, we already figured out that 1.5 times 320 was 480. plus 10 times the number of treats, less than or equal to 540. Okay, so subtract that 480. 30 less than or equal to 10x less than or equal to 60. Got to get rid of that 10, so we're dividing. Now 3 less than or equal to x less than or equal to 6. Oh, if I go down on the number of calories per treat, she can have more treats per day. So now River can have between 3 and 6 treats. There we have it. Okay, so compound inequalities, just to sum it up. Solution of a compound inequality involving or includes the solutions of one inequality as well as the solutions of the other. Compound inequality involving and includes only solutions of both inequalities where they coincide. Okay, so where they overlap is what this is saying. Okay. And there you go. Homework tonight, you're going to be on page 41, do problems 15 through 29. As always, make sure you come prepared with questions. Hope you have a great day.